in pooling. So what do we do in pooling? Pooling reduces dimensionality. Basically, it reduces parameters or computations. So when we study about pooling, there are two types of pooling. One is about maximum pooling and another one is about average pooling. So like we have got this output, okay? So now what we are going to do is, if it is maximum pooling, compare all these four, 38, 20, 36, 49. Which is the maximum over here? 49. 77, 33, 12, 48. Maximum is 77, right? 26, 65, 90, 31. Maximum is 90. 100, 40, 43, 18. Maximum is 100, right? So in average pooling, what do we do? 38 plus 20 plus 36 plus 49 divided by 4. So let me do that. 38 plus 36 plus 20 plus 49 divided by 4. So 38 plus 20, 58, 68, 78, 88, 104, 144, 153, right? So let us try to do this, right? You can find out average for every case now. So actually we are getting it as 143, right? Right. So let me add it. 38, 58, right? So what are we getting here? 143, right? So 143 divided by 4, what do we get now? 3 4s are 12, 23, right? So around 36, right? So that is what being written over here. Similarly, 77 plus 33 plus 12 plus 48, what do we get? So divide it by 4. So we'll be getting around 43. So basically what we are trying to understand over here, it is taking in maximum pooling, it is taking the maximum value, and in average pooling, it is what it is doing actually. It is just finding the average of each 2 cross 2. Hope it is clear to you, right? So just we have understood what is pooling now. Now we are going to study striding little more deeper. So say we choose a stride of 2. Okay. So what we have seen in the previous case was stride of 1. So now if it is stride of 2. So while convoluting image, we will take 2 steps, both in the horizontal and vertical direction separately. So the dimensions for stride S will be, say for example, input is n cross n and padding is p and stride is s, filter size is f cross f, and then this will be the output formula now. So the stride helps us to reduce the size of the image, particularly use feature. So let me show you now, right? So let us try to solve some cases and we will try to understand, because this is very important concept. That's why I'm giving more importance to this, right? Okay. So let me take a pen now. Okay. Say for example, I have 3, 3, 2, 1, 0, and then I have 0, 0, 1, 3, 1, and I have 3, 1, 2, 2, 3, and then here again I have 2, 0, 0, 2, 0, 0, 2, 2, right? And then 2, 0, 0, 0, 1. This is what I have now, right? So the next thing what I'm going to do is, right? So I need a kernel also, right? So I'm using 3 cross 3 kernel, right? So let me use different pen now. So kernel is 0, 1, 2, 2, 2, 0, and then 0, 1, 2. So now can you tell me what will be the size of the feature map? Yes, you are right. So 5 minus 3 plus 1. So which must be 3 cross 3, right? So let us try to do that now. So what will happen now first? This kernel, we will be placing it over here. The first we will be placing it over here. So 3 into 0, 0, 3 into 1, 3, plus 4, 3 plus 4, and then here 3 into 0, 0, 1 into 1 plus 4, right? So what do we get now? 7, 8, 12, right? So what is the answer now? So I'll be getting it as 12, and the next case it will be doing for here, right? So it will do for here. So what will happen now? 3 into 0, 0, 2 into 1, 2, plus 2, 4, plus 2, 6, plus 2, 8, plus 4, right? 12. So I'll be getting it as 12. Then the next one, I have done it already. So I'm writing it over here. 10, 17, 19, right? So 9, 6, 14, right? So this is the feature map I'm getting, right? So the feature map I'm getting it as 3 cross 3. Randomly we will check something. 17 means what will happen? So this will be 1, 2, and then this will be the third one, right? So this and this one, right? So when we take this one, just let's random check, right? So check whether we are getting 17 now. So 0, 1, plus 3 2s are 6. So 1 plus 6 plus 1 into this 2, that is 2, plus 2 into this 2, 4. Then there is 2 into 0, 0, 0 into 0, again 0 into 0, 0, 0 into 1, 0, 2 into 2, 4. So 8, 10, 16, 17. Yes, we are right. Right? So this is clear. So this is the input, this is the kernel, and we got the feature map. And we are clear with the formula also. We have done stride 1. So which means we have moved one by one, right? So this is what we have understood about it. Now in case, if I am going to do padding, what will I do now? Padding means, what did I say? We have to add zeros. This is what we have seen, right? Let me erase this because we have done this, right? So in padding, what did I say? We add zeros because when we are doing this, we got the output also as 3 cross 3, which means we are losing some information. We do not want that to happen. That's why we are doing this, right? So what will happen now? See, for example, what is going to happen now? So the first operation will be done over here. Let me take some other pen now. Okay. So what will be the first operation? This one, right? So this is what will happen now. Here also there is 1 0, right? Sorry, right? So this is what will happen now. So 3 cross 3. So this is what will happen now. Now when you do this, what will be the output now? So you can calculate and tell me, right? So now this will become 0, 0, 0. Another case also 0. This will become 3 2s or 6. Again, these all become 0, right? So this is how we will be getting the answer as. Now let me show you the output now. Am I clear with this? See, 0 into 0, 0, 0 into 1, 0, 0 into 2, 0, 0 into 2, 0, 3 into 2, 6, 3 into 0, 0, 0 into 0, 0, 0 into 1, 0, 0 into 2, 0. So let me show you the output now. Okay. So what output I will be getting now? This is going to be really interesting. I do not have enough space. That's why I'm writing like this, right? Right. Fine. So what did we get actually? We got it as 6, right? So we got it as, let me change the color. So we got it as 6. Similarly, we will do, and we will get it like 6, 14, 17, 11, 13, sorry, not 13, 3 actually, right? 14, 12, 12, 17, 11, 8, 11, 6, 10, 17, 19, 13, 9, 6, 14, 12, right? 4, 4, 4, 4, 6, 4. See, look at the beauty of this. Now what happened? Previously it was 5 cross 5. When you add zeros in all the places, we are getting output as 5 cross 5, which means we are not losing any information. That is what the aim of padding was. Hope it is clear to you, right? So what has happened over here? What has happened over here, right? So I think 10, 17, 19. So it's the center operations, right? So that's the reason it is remaining the same. 12, 12, 17, 12, 12, 17, 10, 17, 19, 10, 17, 19, 9, 6, 14, right? So the center thing is there. And here also, we are not losing any information. That is the beauty of it. So when I do padding, how does the formula change? So input minus k plus 2p, right, divided by s plus 1. So let us try to substitute. What was input actually? 5. Kernel was 3 plus how many padding layer we added? Only 1, right? So 2 into 1 is 2. Divided by yes, we moved it by one stride only. We have not yet seen the stride yet. Plus 1. So 5 minus 3 is 2. 2 plus 2 is 4. 4 plus 1 is 5. That's why we got the output as 5 cross 5. Is it clear? Yes. So in this case, if you do maximum pooling, what do we do? Yes, you are right. 14. And here we will be getting it as 17. Right? Here we will be getting it as 11. And here we will be getting it as 19. In case if you do average pooling, what will happen? Yes, 6 plus 14 plus 14 plus 12 divided by 4. 17 plus 11 plus 12 plus 17 divided by 4, right? So I think it is clear to you, right? So this is how, so now we know how to get the feature map and how to do padding, right? And let me tell you the striding also, right? So when we talk about stride, ignore these zeros now, right? Okay, right? So let us try to understand this now. Okay, so what are we going to do now? Just we are going to understand about striding, right? So as I told you, this is really easy, right? So in striding, say for example, I'm going to use stride 2. So what will happen now? The first thing it will be doing for this one, right? So what do we get answer as, right? We will be getting answer as 12 only, right? Fine. So now striding is equal to 2 in the sense, when we did stride equal to 1, what we have done? The second case, we were keeping it over here, right? So when we talk about stride is equal to 2, we will be leaving this one and we will place it over here. So what will be the answer now? 17. Similarly, since stride equal to 2, here also we will be leaving this and then we will take this one. Am I clear? Similarly, this one. So what will be the answer now? We will be getting 12, 17, 9 and 14. Is that clear to you? So what are we doing when we write stride equal to 2? The second sliding, actually it should happen over here. But since stride is equal to 2, it is moved to this place. Not only horizontally, even vertically, we have to follow the same. So what is happening now? When we do stride is equal to 2, we are getting output as 2 cross 2, right? We are getting output as 2 cross 2, right? So what is happening here? What is the formula now? I minus k divided by s plus 1. What is the input? 5 minus 3 by stride 2 we used plus 1. So 2 by 2 plus 1, which means 1 plus 1, which is equal to 2. It's clear, right? So what is happening here? We have input. We are using a kernel over here, which is giving us a feature map, right? So that is point number 1, right? So if you include stride equal to 2, by default stride is going to be 1 only, right? In case if you write it as 2, it will leave one row or one column and move to the next one. And then we have studied about padding. Padding means what it is doing? It is adding zeros around so that we are not losing any information over here. This is what we have studied, right? So when we use input and kernel, what was the formula? Input minus kernel plus 1. We had 5, so we use 5 minus 3 plus 1. So we got it as 3 cross 3, that we remember. And then whenever we do padding, what formula we were using? Input minus k plus 2p divided by s plus 1. So in that case, we have used stride as 1. So that is why 5 minus 3, we used 1 padding divided by s is 1. So what did we get? 5 minus 3 is 2, 2 plus 2 is 4, 4 plus 1, 5 cross 5. That's why I said we are not losing any information. So in this case, if you use stride as 2, it will change, right? Clear? Yes. So this is another formula. And then here, what did we see? When there is no padding and when there is striding, what we have used? I minus k. There is no padding, right? So this term goes 0. So definitely this striding, right? Plus 1. So by default, you can remember this formula. I minus k plus 2p divided by s plus 1. I minus k plus 2p divided by s. So input, kernel, padding, striding, right? So this is what we have seen over here. People write with a different formula, right? So the filter is moved across the image left to right, top to bottom, with 1 pixel column change on the horizontal movements, then a 1 pixel row change on the vertical columns. So the amount of movement between applications of the filter to the input image is referred to as the stride, and it is always symmetrical in height and width dimensions. So the default stride in 2 dimensions is 1, 1 for the height and width movement. The last one, what we are going to study is about flattening. So now once the pooled feature map is obtained, the next step is to flatten it. What do we do in this flattening? We will be transforming the entire pooled feature map matrix into a single column, which is then fed to a neural network for processing. Right, so this is what we should know about flattening, right? So what do we do over here? Let me show the previous picture. We have seen flattening over there, right? You can see over here, right? So flattening, right? So this is what we have seen. So what it will do? It will flatten 3D volume into 1D vector, right? 3D volume into 1D vector. So whenever we do this processing, what will happen? We will be having few fully connected layers. We will be doing flattening, right? We will be flattening, right? The fully connected layers in the sense, don't worry about it. It is something similar to the one we have studied in regular neural network, right? So in case when you write the code, how do we write? So maybe I have written img underscore shape equal to 28281. Let it be the shape. So how I am setting up the model? Model is equal to sequential, and I'm adding some convolution layer. So for that, what I'm writing? Model dot add, right? Model dot add convolution 2D 6,2 input underscore shape is equal to img underscore shape. I'm using convolution 2D, right? I'm using adding a layer over there. And then I'm adding ReLU activation layer. So how I am adding? Model dot add activation ReLU, right? And then I'm adding pooling. How do I add pooling? Max pool 2D of 2. since I am using maximum pooling, I have showed for maximum pooling. So very simple, right? So we give the input, and whenever we set up the model, we will be using sequential model. Convolution layer, we are adding like convolution 2D. We have to add activation. So we are writing add activation. And then for pooling, I have used maximum pool 2D, right? So from this, what we can conclude is these are useful for image classification. CNN are useful for image classification. That is what we have seen, like how to, like classify it as zebra or bird, right? We have seen some cases. And then it is being used in self-driving cars, right? And then facial recognition and feature extraction classification. And we understood that CNN merges input values and then filter, right? And then when we add or feed new images, so that we get probability for object or describing images, right? So hope it is clear to you, right? So that's so interesting to know about convolution neural network. So just I'll give you a recap on it, right? So uh, first is the input image, input, and then we have kernel. When we combine this, we get feature map. That's what we have studied. Here the convolution. So we are convoluting with the help of ReLU. And then we are doing pooling, right? So pooling in the sense we have studied about maximum or average pooling. And then the next convolution layer with ReLU, then again pooling, then convolution with ReLU, then pooling, then we are flattening it with so that we can change from 3D to 1D, right? So hope this is very clear to you.